Let's start off with a couple of questions. First, about life and work on orbit. Jeff, for you, it's been a busy few weeks for you and Kate and the rest of the crew with visiting vehicles coming and going, a lot of research being conducted on board. Give us a sense of the choreography that is being undertaken to accomplish all of this.
Well, you're right. The last few weeks have been busy. Of course, we transitioned from Expedition 47 to 48, and Kate and Tak and Anatoly arrived safely on their Soyuz to join us on Expedition 48, and they didn't have a whole lot of time to get their feet wet, you might say, on board the station, acclimate to the environment before we had supply ships showing up. First, a Russian Progress supply ship arrived late one night, and then a little over 24 hours later during the day, the SpaceX Dragon arrived, and of course its arrival marked the start of a bunch of new work. We have rodent research that we had to quickly get on board, and Takuya was dedicated at that, getting them safely in their habitat and up and running. We've got some great research on board the Dragon. You've heard of the heart cells experiment and other experiments. Of course, there's supplies and equipment coming on board that we had to get offloaded, and we're in the process of doing that and integrating that new equipment on board station. And of course, it brings many more experiments, as well as in the external compartment of Dragon. It brought the IDA, or the new docking adapter, that will accommodate the new commercial crew vehicles scheduled to fly here in the very short future.
And we'll talk about that IDA in just a moment. Jeff, you know, they say that seniority can't be beat. In the cosmic sense, August 24th marks a milestone for you, as you will surpass Scott Kelly's short-lived record for the most amount of days in space by a U.S. astronaut, 520 days. This, your fourth flight. What does that milestone mean for you personally? And what does it say about the longevity of the station and its ability to sustain a permanent human occupancy?
Well, I think we would all agree that it's an honor to spend any day in space, and certainly to have accumulated that time is truly an honor for me. But I think you bring up the bigger point in that this program, the scope of this program of the International Space Station, I can remember when Freedom was announced in 1984, and having a desire to be part of it as early as 1985. And then, of course, it morphed largely because of geopolitical situations in the world to the International Space Station in the early 90s. And to be part of that, to really represent a really amazing team, especially when you look back in hindsight at what the international team accomplished, to integrate what used to be Mir 2 and Freedom, the elements of that, into the International Space Station, bring Russia on as a partner with the other partners that had already joined Freedom, to integrate this new station and then to begin building it, and then to permanently man it. 15 and a half years, going on 16 years now, we've had permanent human presence in space. And it's been largely very successful. We've had setbacks, we've had disappointments, we've had struggles to work through, we've had challenges, but the team has stepped up to that. And to be a part of it at the beginning, in the middle, finishing out the space station, and now when it's in the full utilization mode, and really stepping up in terms of the greater scientific community on the world recognizing its potential and getting into the doorway to get their research on board and to see it blossom in its utilization. That's really the bigger story to me personally.
Kate, let's turn to you for a moment. Have your first weeks in orbit been everything you expected them to be, and what has been the most stunning aspect of life in space so far for you?
Yeah, I think nobody can really quite prepare for your first few weeks in space, and it's absolutely amazing. It's incredible, and I say this even working at NASA for 7 years before I flew. So we see in mission control, we see the space station on the big screen all the time. It almost feels like home, like your living room. It's that familiar. Even all the cables and the wiring and the lab that you see around us. But that's nothing like actually being here and experiencing even these same walls that I saw all the time on television. To see that in reality, and to actually get a chance to work with some of this equipment has been absolutely incredible. And I'm a little bit split between what's more fascinating to me. I look out the window, and every astronaut says this, but truly the Earth is more beautiful than you can ever imagine. It's just not something that you can conceive of from all the pictures. We're starting to do more with high-definition video, and I think that brings that to people around the world to get a chance to see what we see. But I'm pretty split between what's more amazing to me, the planet, and actually getting to see the space station. When you look out the window, you see the equipment surrounding you, and you can see the entire space station from the perspective of the inside.
Kate, research is the name of the game on the International Space Station. There's worldwide interest in your upcoming DNA research activities. Tell us a little bit about what is coming up for you in regard to that research and your goals and expectations.
Yeah, we've had some incredible research that's arrived on the Dragon vehicle. The SpaceX 9 mission has brought us both topping off all of our research supplies as well as incredible new facilities. And one of the things that folks are very interested in is potentially doing the first DNA sequence in space. That's really a testament, I think, to the ground teams that have put this together. There's folks that have worked on this project for years now, and it's not an easy thing to take a piece of Earth equipment and launch it into orbit and actually fly it on the space station. But the benefits are huge. The potential to understand the technology development of how this equipment works in microgravity. Fluids behave differently, bubbles move through systems differently, so we're learning a lot just from the technology development, but then it's also an application. So we can understand a whole number of variables that change in response to either microgravity or the radiation environment in low Earth orbit. And we can actually understand that at a real global level and start to look at not just one or two genes, but 10,000s of genes, 30,000 genes, and get all of that data all at once.
As far as worldwide interest is concerned, no shortage of that when it comes to your upcoming spacewalk to install that first international docking adapter to the forward end of the U.S. segment of the station. Tell us a little bit about, first off, the extraction process, how the IDA will be pre-positioned to set the stage for your excursion outside.
That highlights one of the capabilities that has been developed over the years, and that is how we do robotic arm operations. In the beginning, the crew on board did virtually all of the operations, with the exception of maybe just setting the arm up, getting it operational, and then putting it away, so to speak. But over the years, the ground has developed more and more capability, and now they do 90-some% of the robotic arm operations from the ground. And that includes the extraction of this IDA from the external bay in the Dragon cargo vehicle. So they will pluck it out of the bay, and they will put it at the very front end of the space station on the pressurized mating adapter where the shuttle used to dock, and approach that PMA and be just very close to it when we go out the door. And as we go out the door, they'll bring it in to within a couple of inches of its mating interface, and then we'll go out there and do the final attachment of the docking adapter, and then of course they'll ungrapple and move it away. So that'll be the big picture of the choreography to get it out there in place, and then of course we'll finish out the installation of cables, power and data cables and whatnot on the IDA itself during the course of the spacewalk.
And in that regard, for both of you, if you could give me a bit of a detailed rundown on what tasks each of you will be responsible for, how you work in tandem, how you work apart from one another to get the IDA actually physically mated to that pressurized mating adapter at the forward end of Harmony.
Yeah, it's actually, we've got the Olympics coming up here, and it's actually a little bit like a synchronized swimming operation. So we're going to work in tandem with the ground teams, and Jeff and I will be going out. We're going to be on clock positions at the IDA. So it's actually quite a huge piece of equipment when you see it up close. It's meters in diameter, and so we'll be holding it from either end of the clock position, and the robotic arm's going to bring it in towards us. We'll continue to bring it in station, and then ground teams are going to do some complicated operations to drive the hooks. That's going to be controlled from our internal crew member, Takuya Onishi. Will be working that, and ground teams will then do some operations to bring that adapter all the way into station and establish that, that mating compartment, that docking adapter, for future commercial crew vehicles.
Kate, if we can get the mic back to you for a second, this will be your first spacewalk, always a prime milestone for any astronaut. What are your thoughts and expectations? What are you looking forward to the most as you step outside and become a satellite in space?
Well, quite frankly, I'm not sure how the view can get any better than it is from the cupola already. So I don't know that I have any expectations beyond, I can't even conceive of what this is going to be like. In terms of the actual work, we train for hundreds of hours, and there's a huge amount of effort on the ground that goes into this. We have teams in our neutral buoyancy lab that help train us. They weigh us out so we have all 6 degrees of freedom, and we can learn how to use the tools and all the operations. There's an entire EVA team on the ground that's helped us get ready for this spacewalk and has done the training for both of us for a number of years. And of course, Jeff is experienced at this, but I think I'm just going to rely on the training and the experience that I have on the ground and the preparation that those ground teams have given me. And definitely, we're going to be working hard, but I will try to take a few moments to enjoy it and get a few pictures of this beautiful new hardware that we're adding to the front of Space Station.
And Jeff, for you, this will be your 4th spacewalk spanning 16 years in both U.S. and Russian spacesuits. What sense of history do you have? You're the history buff on board. What sense of history do you have in yet another milestone being added to the chapter of the International Space Station?
Oh my goodness, well, in the context of doing a spacewalk, of course, spacewalks are a big part of the history of the ISS, made it possible. We've, in the program, I think to date have accomplished, going on 200, 180 some or 190, maybe now more spacewalks in the construction and maintenance of the space station. And as you mentioned, in both U.S. and Russian suits. And participants from all of the partners have been in the core of the cadre of astronauts and cosmonauts that have conducted that. So that's a big part of the history. In terms of the IDA, the docking adapter, that opens the door to commercial crew vehicles. And that is the next major chapter on the horizon being developed in the plan to fly. And of course, we don't know what that's going to open up in the future, but it is a significant door opening up in the in the history of human space exploration. That in the context of the ISS, which again is the most significant technological achievement, in my opinion, in history. When you consider the complexity of this thing, how long it's been flying, the international scope of it, the technological scope of it, and then the fact that we sustain it logistically and operationally for so long. And the partnership itself, among all the partners, has never been better, in my opinion. In my experience across the entire program, it's never been better than it is right now. So even from an international relations point of view, I trust that it serves as a very positive example to the world below.
A new era in human spaceflight about to dawn on the International Space Station through your spacewalk. We'll be watching and looking forward to every minute of it. For Jeff and Kate, thank you so much for your time today. We appreciate it. All the best as your colleague floats through, and fly safe.
Thank you very much, Rob. Great talking to you today.
Station, this is Houston ACR. That concludes the JSC-PAO interview. Thank you.
Thank you, JSC-PAO. Station, please stand by while we reconfigure video and audio communications.